Hello class, this is a video tutorial on exponential equations. Exponents are another term for indices. Exponential equations refer particularly to when the pronumerals are themselves the indices. So, take a look. This is not an exponential equation. This is a quadratic equation. We have x squared equals 9, and we know how to solve this by taking the square root of both sides. It will give us positive or minus 3. Now compare that to 2 to the power of x equals 8. Notice how the pronumeral themselves, right, is the indice, right? So we solve them by using our knowledge of index laws and reduce the base of the exponential equations. So let's do a few examples here. Let's do 4 examples so we get our understanding of this. So what we do when we have 3 to the power of x, we look at this base and we're going to change every other expression in terms of the base that we see. That's the smallest base. In case you've forgotten, that's the base and x is the index or the exponent. So let's change this. So 3 to the x stays the same. And I know 81 is 9 squared. Okay, we're getting closer because we're getting closer to 3 as the base. 3x is equal to, and I know 9 squared, right? Sorry, 9 is 3 squared. So I replace the 9 and the square is still there from the previous one. So this becomes 3x equals, using our index laws, power to the power is multiplied, so this is 3 to the power of 4. Therefore, we conclude now x is equal to 4 because they both have the same base, which means x has to equal 4. And that's how we solve it. Now, no matter how complex the expression may be, we still follow the same idea and reduce everything so that they have the same base. So in this case, 5 is the lowest base. This becomes 5 to the power of 2x minus 1 equals 25. I know is 5 squared. Well, they both have the same base, so therefore we can conclude 2x minus 1 equals 2. So that expression is equal to that expression, and we solve this one. So 2x equals 3, x equals 3 over 2, or 1.5 if you want to use a decimal. Let's move right along. In this example here, it's not that obvious how we would reduce these. So in cases such as this, we reduce everything we possibly can. So for example, I know 8 is 2 to the power of 3, 2 times 2 times 2, all to the power of x. And I know 4 is 2 squared. Okay, so this becomes 2 to the power of 3x equals 2 squared. Well, then we can conclude now, therefore, 3x is equal to 2, and x is equal to, once again, 3 on 2. That's a coincidence. I didn't see that happening. But anyway, so long as you understand what I did, how we reduced 8 to become 2 to the power of 3. Okay, let's do it again. 4 I know is 2 squared to the power of 3x. 8 I know is 2 to the power of 3 to the power of x plus 3. Okay, expanding this becomes 2 to the power of 6x. 3 times x is going to be 2 to the power of 3x. 3 times 3, expanding the index laws, it will be plus 9. Therefore, we can conclude this will give us 6x equals 3x plus 9, 3x equals 9, and x equals 3. So I hope that gave you an insight into solving exponential equations by reducing the bases and using your index laws. Best of luck.